Okay, so we are discussing another topic of geometrical optics, that is microscope. So first of all, what is microscope? An instrument that gives you a large image of the object that you cannot see from the naked eye. For example, the viruses, the bacteria, for the biological work that we cannot see from the naked eye. For that, we are using the instrument that is called microscope, right? So the microscope is divided into several branches, but the main are two. I know stereo microscope is all there as well, but let's discuss first this simple and compound, right? So here first of all let's discuss about the simple microscope. Okay, so as the word simple mean it has the simple structure, so it only have one convex lens, and I hope you know the reason that why we are using here convex lens, not concave, right? So now let's go with the image formation, and then I'll be telling you the position of the image, the nature and the position of object, right? So first of all let's draw a lens here. This is called biconvex lens, or you can say double convex lens, right? So here this is principal axis, we have focus here, one more point, and this is O, optical center, right? And here let's make human eye. Alright, this is the human eye where the object will go. So first of all the object is placed here between F, right? So we know the rules for this, when this is parallel to this, so it will go like this, right? And the line that goes from the optical center come back through the it, right? So here they are parallel to each other, and we know that parallel rays never meet. So what we need to do is we need to make a virtual image like here. They'll meet at some point like this, in this way they'll meet. Yeah, just give me a minute, it will be like this. Yes, the object will be here, now the image will be here. This is image, enlarged image, right? I hope this is clear to you, like the process here, what is happening here. This is lens, here is the object, this is object, right? So when the rays are parallel to it, it will pass through this. So, and let's apply the second rule here, that the line that goes from the optical center passes through the same path. So here you can see they never meet. So of course for the image formation we need the rays to meet, but here they are not meeting. So what we'll do is we'll move them backward and we'll create a virtual image, right? So here there will be a virtual image, and this is the enlarged image. Okay, so now let's talk about the position of object. Position of object, like where the object was placed. So here between F, so it will be, yes, between F and O. What is F? F is the focus here, and O is the optical center, this, right? What is the position of now image? Position of image we are talking about, right? So the position of image here will be near the just give me, let me write and then I'll tell you. Image developed at near point. Now what is this near point? Here this was very close to the human eye, right? And we know, like, the distance for a clear image, we need the distance of 25 centimeter. Like if the object is far away from it, so it will be like give you the image that is, it won't be clear, it will be blurred. And if you will move more close to it, so yeah, it will be blurred and you cannot see it. So the maximum or minimum distance required for the human eye formation, like the image formation, is 25 centimeter, right? So the position of image here is near the point. Now near the point means here, it would be 25 centimeter. So this is called the near point here. Okay, so now talking about the nature of the image, like what kind of image it is. So here the lines are not actually meeting, so the line that do not meet actually are called virtual image, right? So the image will be virtual, and we know the thing that is virtual is erect as well, and it is magnified. Of course this is a microscope, so the image would be magnified, right? So now let's move to the formula of it. Here you are getting that the image is formed, that is enlarged. Now the question arises, how much? How much? Like you don't know how much the object is, the image is magnified 1 time, 2 time, 3 time. To identify that, we have a formula for it. A complete formula is there of it. Just give me a minute. So yes, let's move to that formula now. So m is equal to o dash upon theta. I know you may be thinking the formula of magnification is image height upon object height, right? Or image size upon object size. So yes, it is, but let's drive that. Let me make 2 diagrams first. This is object and this is human eye, right? I'll elaborate this, just give me a minute. This is object and yeah, this is theta. Let's draw another. This is the lens, convex lens, and here is the human eye. So distance here is 25 centimeter as well. 25 centimeter, right? This is theta naught. This is focus, right? And the object is placed between the focus as we have discussed here. And this is image. Okay, so yeah, I made these 2 diagrams. So the first diagram is showing you that here is the object and we have eye. So now we need the enlarged image of it. Here is the object and we need a enlarged image. So what we'll do is, here we have the eye. This is human eye. We'll put the convex lens here, right? So that we can get the magnified image. And here we have O naught. Here I have written this, right? So here this is the magnified image. This is the distance, and yeah. So now magnification is equal to O naught upon O, right? So let's apply tangent theta here. This is from the trigonometry, and I think you know, every one of you know here. So trigonometry here is equal to, tangent is equal to perpendicular upon base, right? And here in the first diagram, what is the perpendicular here? It is O, right? And talking about base, so base here is D, right? So it become O upon D. Now talking about theta dash here, so it is tan. So it is also equal to perpendicular upon base, right? Okay, so here you can see we have P upon B is equal to I upon D, right? And here we have find the value of both, like the theta and theta dash, right? So now we need to put this in this formula. M is equal to, we know, theta naught. So here we'll put I upon D, right? I upon D, and here we'll put O upon D. So the D cancels from D, and we have the magnification is equal to I upon D, right? This is the magnification formula for now. Now to drive more, we need to do is, as we have just give me a minute. So first of all, magnification is equal to I upon O, I upon D, right? D cancels from D, so it is size of image upon size of object. This is the formula that we have studied before, right? Like, yes. and it is also equal to the distance of image upon distance of object. Now how? So for example, you have the object, the object is of size of 3 centimeter, right? And talking about image, so it is 6 centimeter. So what we'll do is 3 ones are 3, 3 twos are 6, it will be 2 centimeter, right? And talking about distance, so for example, we have distance of 4 centimeter, the object, and the image is of 8 centimeter. So what it will be, 4 ones are 4, 4 twos are 8. So by this, okay, so here magnification is equal to size of image, size of object is equal to distance of image upon distance of object. Now you may be thinking how. So I can give an example from it. For example, as we know that magnification is equal to O dash upon O, right? So let's imagine that we have an image, but leave this, let's use this formula. Okay, so let's make sure, like here, suppose we have size of object that is 3, and talking about size of image, so it is magnified of 6. So what it will be, like centimeter, and here centimeter as well, 3 ones are 3, 3 twos are 6, it will be 2 centimeter. This is, I'm talking about size. And talking about distance, so let's suppose we have the distance of object that is 4, and talking about image, so it is magnified and it will be 8. So 4 ones are 4, 4 twos are 8. And you can practice this more and you'll get the same answers. Okay, so by this we can say that the size of image is equal to the distance of image, and size of object is equal to the distance of object, right? Now by this we can say Q upon, we know that the distance is, just give me a yes, we were having a diagram there, like here the diagram was there, F, it was the image, and we made it like the backward end was virtual, right? So here the distance D, that was 25, is equal to Q. The distance is also like represented by Q, so we'll put here Q, and the size of object is like represented by P, right? So it will be Q upon P. Now, and we know Q is equal to D. Okay, so we can also put here D upon P. So now what we need to do is D upon P, and we know D upon P is equal to magnification is equal to D upon P, right? So now according to lens formula, lens equation, we know 1 upon F is equal to 1 upon P plus 1 upon Q, right? So here we will take here minus negative, because we have virtual image, and I have elaborated this like in the previous moment, it was virtual, so we'll take negative here, like we will multiply the negative from it, so it will be 1 upon F is equal to 1 upon P minus 1 upon Q. And if the image would be real, so we will take positive sign, no need to change it, right? Now 1 upon F is equal to 1 upon P upon 1 upon Q. Now we will be multiplying D on both sides, multiply. Okay, so now we are multiplying D on the both sides, so it will be D 1 upon F is equal to D 1 upon P minus D 1 upon Q, right? So it will be D upon F is equal to D upon P minus D upon Q. Okay, so now we know that D is equal to Q is equal to D, so it will be D upon F is equal to D upon P minus D upon D. Because here we have like elaborated that D is equal to Q, so the D will be cancelled from D, so it will be D upon F is equal to D upon P minus 1. Okay, now we are making it plus from here, like we need to do is this cancel from each other, now we will move it there, D upon F plus 1 is equal to d upon p, right? And we now d upon p is equal to magnification, as we have written here. D upon p is equal to magnification. Here it will be m is equal to d upon f plus 1. This is equal to m. Don't get confused here. This is m and that is magnification, right? So here we get the final formula for the microscope, for the simple microscope. For compound it is changed. This is for the simple microscope, and this formula will let us know that how much object is magnified, the image is magnified.